There we go. Um, Alrighty. So just a couple words about who we are. 3C REN, also known as the Tri-County Regional Energy Network. We're a collaborative partnership between the counties of SLO, Santa Barbara, and Ventura, meant to improve energy efficiency in the region. We do this by providing services for both building professionals and households. We're funded by ratepayer dollars that we all pay into through our utility bills. And the benefit of being ratepayer funded is that there's typically no cost to those that we serve. And we're able to return these dollars back to our local economy instead of being distributed throughout the state. We currently have 3 programs. We have our Energy Code Connect program, where we offer industry training, regional forums, and a Title 24 consultation service called the Energy Code Coach. I've listed our hotline number here. You're also able to fill out an inquiry form on our website and receive a response back within 24 hours from our local Energy Code Coach team. Our Building Performance Training program is a standard workforce education program. It's the reason we're all here today. We focus on education and training for high performance buildings and building science. Um, the real goal here is to bring industry leading certification and training providers to the Central Coast. And lastly, our home energy savings program, where we offer flexible home energy upgrades for households and contractors looking to indulge in energy saving projects in their homes. With that said, I am going to pass things off to Chris to get us started this afternoon. Chris, you have the floor. I'll unshare and let you pull your screen up.
Awesome. Thank you. Just give me 1 second while I share. Let me see the PowerPoint. Can y'all see the PowerPoint? See view. All right.
We've got you, we're pulled up in presenter view.
Alrighty. Thank you for that. My name is Christopher Velasco. I run an urban planning consultancy called DOTEC LLC. I also have worked with one of your members to build one of the first hemp insulated ADUs in the state of California. I'm a seasoned urban planner, so I have years of experience working on both ends of the counter, both on the municipal end and also on the developer. And so I understand both sides of the table, as they say. So today I will be going over industrial hemp. Basically, brief overview of installation materials, example of the Clexco ADU, and something that's more pertinent to Ventura County, overlooking their alternative building materials section. So let me get started. So hemp as a building insulation as an installation material. So it's a really versatile and a dynamic insulation material. It comes from a fast growing crop, so there's a lot of carbon sequestration that happens with it. And it's really great at thermal insulation, moisture regulation, sound, etc. So the benefits to hemp construction is a really great reduction in operational costs, emissions, especially in the warmer parts of your respective counties. And it's hydroscopic, so it regulates temperature and humidity quite well. Now, there's 2 types of hemp insulation materials I'm going to focus on. One is hemp bat insulation, and the other one's hemp lime insulation. So hemp bat insulation is, in essence, harvested fibers that are processed to form these bats. They're pretty rigid. They don't require, most of them I've seen on the market don't require a backing. Roughly about 3.5 R3.5 per inch, and it doesn't lose thermal insulation if it's compressed. The issues with it is that there is flammability, and the one company that was certified for use in California has been delinquent almost a year, so I don't think there's anything on the market I can find just yet. Correct me if I'm wrong. I would love to be able to use some of this in my projects, Second one is hempcrete or hemp lime insulation, woody inner core processed into 10 to 25 millimeters. Basically, in essence, replaces a wall assembly. Again, this is a discretionary review process, and I'll get into that a little bit later. It's a jurisdiction by jurisdiction, case by case basis. The fallbacks, despite all the benefits, is that it's very high labor costs to do on-site hemp lime insulation, and there's a lack of a trained workforce, which I'll get into a little bit more. I found out the hard way. Oops, sorry, one sec. I'm having an issue with my slides here. So this is in essence the wall assembly that we used for the Calexico ADU. This was something that was presented to the building department over there. It's very typical hempcrete on-site build. You have your hempcrete, your fiberlath, scratch coat, brown coat, finished plaster. A really awesome building material. So the ADU again was the first permitted ADU using hemp lime insulation in California. The entitlement process was extremely complex and more expensive than real. It's not a standard application. And there was huge issues with the first quote unquote contractor who purported to be an expert in it, but had no experience, and it would cost me to replace the 3 hempcrete walls that they had done that were substandard. So a little bit about the climate in the area. It's climate zone 15, low desert, large fluctuations in daily temperature, long prolonged heat waves exceeding 110. In essence, it's the climate zone of climate reminiscent of Phoenix. It's also seismically active, so a lot of swarms, basically multiple earthquakes in a short amount of time, largest of which was 4.8. And what we've seen was over a 50% reduction in HVAC use. So this is more on the operational costs, operational emission side. So we're getting real world data on it. And it's an awesome in terms of its performance.
Hey, Chris, real quick,
Huh?
I have two things. Do you mind if we pull it out of presenter mode and pull up the PowerPoint as a whole?
Oh, is it presenting as in presenting mode?
It is, yeah.
Oh, I am so sorry. Use slideshow.
Oh, that's perfect.
I thought that was on my end. I could only see that.
No worries. Yeah, we we were having trouble seeing the slide size.
Okay, let me
Um,
there we go. That
this
was
is perfect. And then we had a really quick question come up almost instantly about where hemp insulation is manufactured and grown.
so I'll get to that a little bit later in the slide.
Okay, perfect. All right, we'll continue. Thank
Okay.
you.
So yeah, it's basically Mars, the climate. It's intense, and to have that reduction in HVAC use is a testament to the insulative values of or qualities that hempcrete in this instance provides. So this is a picture of the living room. Now, a lot of lessons learned on this project, not only on the permitting front, but actually on the building front. So you see where the trusses are over the interior wall, that those little sections of hempcrete had to be removed. And on the interior wall, we used hempcrete as inside the wall, but we covered it with drywall for the most part. The exterior walls are pure hempcrete. This is how it was cast in place, little by little, but 2-foot sections at a time. This is what the interior looks like. This is the kitchen. You know, you see the kitchen window and how wide the wall is. It's about 11.75 inches in width. So big learning curve too on that. So this is not quite the best picture, but it's the best picture I could find. It was a little messy still. So you see there's a difference between where the roof trusses are and the wall. The wall's actually wider than, so the frame, it's cast in place around the framing, but it turns out to be I had to have custom flashing made for this because of this sort of difference in elevation. Again, 50% reduction in HVAC use, over 13,000 pounds of CO2 sequestered in the walls. It's an active rental, passive design. As you can see, the roof tilt to shade the house during the hot months, let the sun in during the cooler months, and it has withstood multiple earthquake swarms with no damage. And this is a very, very seismically active part of California. So, speaking of California, there's some really great legislation out there. There's AB 2446, which in essence calls for a 40% reduction in emissions from construction materials by 2035 and an interim target of 20% by 2030. So by next summer, we should have the framework. It's multiple agencies that are leading this as directed by the legislature. Also, the intervening cycle updates to CalGreen. Hemp is really hemp insulation, both bat and lime, could help reach reuse and reduction in embodied emissions requirements associated with that part of CalGreen. And next slide is going to be the regulatory environment. So we all heard about the adoption in the IRC of the hemp lime chapter. California, we do not auto adopt. And that's in large part because we have a very unique set of circumstances, right? Our geography, our climate, our seismology varies across the state substantially. So what works in the northern part of the state, the northwestern part of the state, it's very wet, cool climate, does not work where I am in the part of the state, which is the southeastern part of California. It's a completely different environment. So all those considerations have a unique and stringent code. Section 104.11 of the California Building Standards Code is alternative materials design methods and construction equipment. I will just say alternative materials, so I save myself from saying that whole title, is how I entitled the hemp lime ADU. Every jurisdiction has sort of this in their local operation. However, some jurisdictions are really hostile, and it's really surprising which jurisdictions are hostile and which aren't. I mean, at least in my experience, San Diego, city of San Diego, completely hostile jurisdiction, even though we have a robust climate action plan, goals, a quote unquote green future, very hostile, wouldn't even entertain the idea. Small city of Calexico, California, took a long time to do it, but small town, made me do structural calcs above and beyond, what have you, but ultimately approved it. So it all depends about what jurisdiction you have and what relationship you have with that local building division or building department. So permitting a hemp lime or hemp insulated building. So for manufacturers of thermal insulation, they need to be licensed, and they need to have a license category from thermal insulation manufacturer license from the Bureau of Household Goods and Services. I checked Hempcrete. I thought they had one. They did, but it's been delinquent since April 30th of last year. So I'm not sure if their bat is able to be used in California currently. But again, I said every jurisdiction has its own interpretation. It's all about equivalency, proving equivalency with the code, and remembering that jurisdictions, cities, counties, what have you, are all thinking about liability, right? If I approve this and it falls down and it injures somebody, they're going to say, hey, well, this building division of this county or the city approved it knowing it wasn't equivalent. So therefore, I'm going to sue the county or the city. So that's from a building division perspective, that's what you have to sort of frame um, your thinking when engaging with them. So I took an example of from Ventura County. So basically they have their own way of interpreting section 104.11. It gives the building official the authority to approve the alt build materials based on three general factors. And there's much more nuance into this. I could probably give like an hour-long discussion just on the nuance of this section of the California Building Code and different interpretations of it, but I'll provide an overview from what I found in Ventura County. So there's three main criteria, and that is that the material design or construction method has to comply with all the regs, right? Your building, electrical, plumbing, mechanical. How does it comply, right? That's the main thing of saying, is this equivalent, right? So that's in section 2, equivalency in terms of quality, strength, effectiveness, fire resistance, especially if you're in an interface zone. Hempcrete is an amazing fire retardant. I think they've scored on the E84 ATSM E84 test. It's all been 0. All the tests that have done, and I'm sure there's been local tests done by fire departments all across California, and it's an amazing fire retardant. So this is about equivalency. You have to approve equivalency with all the codes, and you have to write sort of a mini white paper. So the way I did it was I compiled a lot of data from various sources, and I went to grad school, so I have the research science part of me is still very strong. So I, in essence, wrote a white paper on hemp lime insulation and how the building would comply with the building standards code, right? So and isolating hempcrete to say, hey, this is an insulator, right? This is an insulator, and that is the main purpose of this, is being insulation, right? It's hydroscopic in a sense that it self-regulates humidity. It can get wet and it will dry itself out. Only thing is, it can't be submerged in water for very long periods of time, because that, in essence, will cause it to fail. But if you focus on the insulative value of it, that is where you can prove your case. I mean, well, I proved my case was narrowing its, applicability, of saying this is just an insulation material, right? So there are challenges to wide scale adoption. There's a lack of supply chain infrastructure. The farming industry is still reeling from, the hemp industry actually is reeling from the CBD bust. So there are the vast majority of hurd and fiber I've found are coming from the Mountain West, particularly Colorado, Midwest. There's a few on the East Coast, but I used a combination of hurd from Colorado and a little bit from North Carolina. But Colorado, they've been doing it in a long time, so it was really high quality, no dust, good stuff. And another challenge is there's not a lot of people who know how to build with this. It's not a complex system. The French have been doing it for 40 plus years. The English have built whole apartment complexes in the UK out of it. It's really not a hard system. You just have to do it the right way. There's a precise way, and due to your climate, it changes, right? So if I'm going to do, like, for where we are located in a very seismically active zone, our binder ratio is a little higher. So there's more binder to herd ratio than, say, somewhere that has a very temperate climate, like coastal Santa Barbara County. You're probably going to lean more on the herd dominant part of the mixture, right? And again, not in the California building codes, right? So again, there's that one alternate building section, alternate building materials and methods and construction materials section of the code, case by case decision. And that is the main challenge, is that it's jurisdiction by jurisdiction. Now, there is potentially a way to do it through the factory built housing program. However, that's a whole other conversation, right? That's a whole conversation leaning on factory built standards. There's also HUD. But this is for the most people build on site. So that's the premise of this presentation. And I think a really, really big potential for this would be for added value agriculture, water savings, and a just transition to a green future, right? So when you think about added value agriculture, you got to look at California from a farm belt perspective, right? From the San Joaquin Valley up north down to Imperial County in the south, we are the #1 ag state, right? But we use a lot of water, and we use a lot of water producing feed crops that are exported out of state, right? So crops to feed cattle, for instance, uses a huge amount of water that we're exporting. So we're in essence giving our water away. And the farm belts are some of the most disadvantaged, polluted, poor places in the United States. So the ag economy produces a lot of benefits for some people, provides a lot of jobs. However, a lot of those jobs are very low paying and result in generational poverty. But there is a huge potential to process and manufacture the products such as hemp lime insulation or base products for hemp lime insulation or the actual hemp bat insulation. There's hemp wood. There's a bunch of products that can be created from this plant. And it could also be used as a way to sequester carbon, right? Because you're talking about a plant that grows upwards of 12 feet for 4 to 5 months. Can suck up a lot of CO2 from the air. Unfortunately, the state's climate investments program through our cap and trade has a general agriculture sort of funding mechanism, but I think of this as direct air capture, like the original direct carbon air capture, right? Because this plant grows so fast in such a short time. That's where you're getting all your carbon capture done by nature. So it also uses substantially less water than feed crops, right? We're about acre foot per acre, whereas some feed crops can use substantially more than that. So I think there's a huge opportunity in California if the state government would just align its goals into actually investing in farm belts, right? So when the state has all these clean tech and climate tech um, competitions and RFPs, they put them out. They say, "Hey, we're committed to diversity. We're this and that." And if you look where all the funding goes, it still primarily goes to Bay Area, a little bit to LA, even less to San Diego. When in reality, there's a huge untapped market from Chico down to Calexico in this farm belt. So I think it would be wise of the state to invest in our farm belt, because we could create a lot of good out of that and provide living wage jobs, higher paying jobs, and support our manufacturing, because we're the number one manufacturing state in the union. People don't always remember that, but we have this untapped market with bio-based alternatives. So I believe that summarizes my presentation, and I'll be open to questions now.
Awesome. Thanks so much, Chris. Um, We did have one question in the chat that Alex provided a link for, but asking about peer-reviewed studies that you use to demonstrate insulation values, et cetera, of hemp as a building material.
So the process I went under was a few years ago. So whatever Alex provided, I'm sure is the latest and greatest. There's been a lot of development in the space over the last 2 to 3 years.
All right, excellent. Yeah, we can pause it. Are there any other questions out there in the audience for Chris before we move on?
If no other questions, maybe now is the perfect time for me just to chime in and say that a few different things. One, what I dropped in the chat was Cameron McIntosh, who's one of the real leaders in the hemp industry. He had an ASTM C518 test done, and so you can follow that link and take a look at it. But he also then just recently won a nearly $2 million grant from the U.S. Army. I guess it was a Department of Energy grant within the U.S. Army to do testing on insulation values more comprehensively, and a range of other different tests. And the other thing that I'm involved in right now is that there's a New York State Energy Research Development Grant, or New York CERTA, and there are 8 different companies that are going to be participating in this, doing a range of studies on also, fire testing and insulation values for their specific products. So one of the things that I think we've struggled with as an industry is that there just hasn't been that much data to back up, or basically to substantiate what's been proven in Europe so far. But that is coming down the line. It's in process, and so I think I think it's pretty amazing where we've come in 6 years, and I'm looking forward to seeing where we can be in another 6.
Okay, thank you all.
Awesome. Thank you, Chris. Alex, you're up.
Okay, great. So for whatever reason, whenever I switch this to the full presentation mode, I can't use the buttons. And so I will keep it in this mode if it's okay with everyone. There we go. So this is a presentation that I've given a few times now, and was originally given to the students at the University of New Mexico, the School of Architecture there. This is back in 2021. I'd been interested in Hempcrete for a while, but I hadn't put together a presentation, and so that was an amazing opportunity for me to share with the students at the alternative materials class at the University of New Mexico. And I realized before this presentation that because it's several years old, all the examples that I'm showing here are European. And I thought maybe it was time for a proper update to that. But I'll share, just because they're here and I've talked about them before, a cast-in-place renovation project in Belgium by Martens van Camier, a very highly regarded architect in Belgium. A small community project that was created with spray-applied technique in England, and then a multi-family, multi-generational housing project that Stefan Welsh did for himself and his family in Australia. So for me, this was interesting to see the developments around the world as I started becoming more familiar with Hempcrete projects in different scales and sizes. And so now I think this is the new cover for you all. Kind of small, medium, and large, or large-ish projects, all here in the United States. Wally Farms by a designer in New York, Cahill Cool. The Cape Cod Hemp House in the middle by Estes Twombly and Titterington Architects. They're based in Rhode Island. but obviously Cape Cod, the house is built in Massachusetts. And then the Hillside Sustainable Living Project just outside of Boston. It's a multi-phase development where the goal of the project was really around sustainability and reducing the carbon footprint. And so those are some of the more interesting examples that have been built in the last few years in the United States. And I'll share more examples as we kind of move through the presentation. A little bit about myself. I live in Tucson, Arizona now, but I spent about 20 years of my life in Los Angeles. I moved there to go to Southern California Institute of Architecture, SCI-Arc, and practiced at firms big and small throughout the LA area. Big firms like Perkins and Will and Canon Design, and then smaller boutique firms, OX Architects, Hodgson Fung, and then also the last two major projects that I worked on before branching out on my own with Johnson Fain. So a winery project in China where we were the design architects, and then I was the project architect in charge of construction administration for the Christ Cathedral project. So anyone who goes down to Disneyland could go over to Garden Grove and check out the renovation what we did there. It was pretty amazing project for me to work on. And I like to show, obviously I worked on more projects than this. These are 6 of the major projects. And I like to share this because at the top left, when I was working on Carlsbad High School, Perkins and Will was really making an effort for all of us to get LEED certified. So I'd been practicing for a few years already, but wasn't a licensed architect. And so I thought, well, this is just a single test. I'll give it a try. Failed on my first attempt, but passed the second time, and really learned a whole lot about where sustainability was going, at least from a U.S. Green Building Council perspective, talking about toxicity of materials, all the different aspects of what to them was making a building sustainable. And then by, let's see, 2007, so almost a decade later, working on the Christ Cathedral project, during that process, the house that we were renting in Redondo Beach was water damaged and black mold formed. And my partner, who was already struggling with health issues, got really sick. And so when we got out of that environment, I started researching both from a personal and professional perspective, what was the most mold-free building assembly that I could build a home out of if I was able to build my own home. And the word that came up on the mold forums that really surprised me, because I'd never heard of it before, was Hempcrete, or hemp lime construction. And so I was curious and started the kind of path of research, let's see, 2019. And but it was still kind of an academic pursuit at that time. And in 2020, that started to change. I started to become a little bit more committed to this field of research and trying to understand how, would it be possible to build here in California? And originally thought that proposing a project in Joshua Tree made a lot of sense, because I just assumed the building regulations would be more relaxed, and that it would be an interesting kind of alternative building material to present potentially for an Airbnb project. So that was another kind of step in my my overall research. And then we decided to move to Colorado, and then later to Santa Fe, New Mexico, as part of moving closer to what I thought might really be the epicenter to hemp lime or hempcrete building in the United States. And so, as Chris mentioned before, a lot of the herd that he was getting was either coming from Colorado or North Carolina. And so we were able to visit some of the processors out in Colorado and just become more familiar with some of these different aspects. So big picture, what is hempcrete? One way we can talk about it is as a bio-based material developed in Europe. This is really, obviously hemp has been in the world of construction and in use as a material for thousands of years, but hempcrete itself, as far as I understand it, really comes out of the early 80s, restoring traditional buildings in France. And so it's made out of hemp hurd, lime binders, and water. And I like to stress it's really a non-structural material. A lot of people hear hempcrete and they think, oh, it must be like concrete, or it's a low carbon concrete. Some people put it out there in that way, but really it's a non-structural, fire resistant, mold resistant material. A lot of people talk about it as a potentially zero carbon or carbon negative, different way. I like to talk about it as a low carbon, high performance solution, because as soon as you say net zero, people start, asking for the data and really trying to drill down on it. And I think as I mentioned, as we were in the transition there, that gathering data and peer-reviewed studies is basically where the industry is now. There have been a lot of owner builders who really pioneered the space, but we're moving into a new era where we're trying to get more testing done so we can really start to build at scale. So obviously all of this emerges really from the 2018 Farm Bill. There have been hempcrete projects that have been built prior to that, but the Farm Bill obviously accelerated the interest in growing and building with hemp. So the Maison de Turquie, as far as I understand, the one on the left is the house for which hempcrete was originally developed. As you can see the lime plaster on the exterior, and the hempcrete was the infill, the insulative infill between those half timbers. So again, hemp hurd looks kind of like small wood chips. There are debates about what the best size is. Every builder has a slightly different opinion from those that I've talked to, but say somewhere between half an inch and maybe an inch and a quarter, maybe as much as an inch and a half. Lime-based binders with putzolans and other additives, and of course water. One of the things that's helpful to understand is that if we're talking about hemp, what we're really talking about, or hemp hurd, we're talking about the inner portion of the plant. So the exterior is the fiber. That's where all the textiles, the sails and rope that got us over to the New World were used from. But the interior part is the woody shiv or hurd. I think another thing that's helpful to understand is, when people get concerned that we're going to build out of a material that's been on the substances list, this is quite a different material. CBD on the left, as Wayne so often has told me, is compared to Christmas trees. So they're growing it for the flower, for the psychoactive properties in the flower. If you look at the slide on the right, or the image on the right, that's industrial hemp. And there's as many as 1 million plants per acre that are grown, and precisely to get them to grow vertically, to enhance the plants to grow more stalk and less flower. So it's you can see totally different in the way that it's grown and what's truly being harvested. So as I'm kind of educating myself and moving through this practice and understanding more about the material, for me, it started to change my definition about sustainability and wellness in architecture. I said that when I was working at Perkins and Will, we were getting, we were encouraged to get LEED certified. That trajectory, as I understood it, was really about doing less and less harm. And as I started doing more research about hempcrete, I really thought this is a paradigm shift. We're moving into a world that's far more bio-based, and we're not talking about reducing toxins. We're talking about building without toxins. Now, it's, I think a lot of people who know lime is a caustic material, so you do need to take care when building with it, but it's non-toxic from a perspective of working with it or living in the environments that it's created out of. So these are two different slides here. One, a photo of the San Luis Valley, a hemp farm that was grown there. Global Fiber, I guess it was Formation Ag at that point, collaborated with Patagonia to do a test grow, and because most of the I'm having trouble late in the afternoon. Most of the hemp that they were growing from textiles was coming from China, and they wanted to do experiments to see how well hemp would grow in the U.S. And obviously, the slide on the right there is Cancer Alley. That's in Louisiana. A lot of the products that we put in our building materials and our buildings are, they're made with toxic chemicals and are really harmful, not just for the people who are living in the environments, but also the communities in which these materials are made. And so there is, I think, when a lot of people start talking about bio-based materials and they start talking about reducing toxins in the buildings, it's also very much about, to me, environmental justice, because a lot of the places where these materials, the toxic materials, are made are some of the poorest communities in the country. And of course, it's harder for people to fight back. So as I'm thinking about this, we're moving from a world of less and less harm to truly regenerative building materials and truly regenerative projects. Made me think about obviously hemp, bamboo, cork, materials that can be grown or rapidly renewable versus other strategies. We think about batteries and electric cars and things like that. There is a cost to those, and so the image on the right is a lithium pit mine where we get rare earth metals from. But you could imagine that of basically any material, any metal. We're digging huge holes. As I said, I live here in southern Arizona, and some of the mines nearby here, the copper mines, silver mines, I mean, it's just astounding how deep the holes are in the ground to be able to mine these materials. So part of the research was also for me looking at books like the Joseph Allen's Healthy Buildings that came out in I think March or April of 2020. Talk a lot about cognitive performance and how we can get the importance of fresh air in our buildings and making the business case. So two professors, one from School of Public Health and one from the business school, making the business case for why we should make our buildings healthier. This was happening, of course, at a moment when we were both working, educating our family, cooking. People weren't going to hospitals really as much, so we were, healthcare aspects, other areas where we've studied in detail and have data about performance. Now they're all taking place in our homes. And I thought it was interesting to think about how few studies there are about performance in the home. Like we don't talk about how we did in terms of making dinner or the quality of time that we spend with our family, and yet health is it's an important aspect of wherever we are. Kiss the Ground was another documentary that came out around that time, and this was a real eye-opener for me in terms of talking about regenerative agriculture as a potential solution for climate change. And so, literally those two books, book and documentary, to me, when those two things come together, you have a potential solution that's about really changing the paradigm around architecture. The other book that I put up here is The Drawdown, something that I became aware of back in 2018. This is Paul Hawken. So any of you guys are Erewhon fans, it's the same Paul Hawken. There are 100 different examples of how to reduce carbon, and hempcrete is one of them. So I was fascinated even back then. I was, that was right around the time when hemp was legalized. So I guess the seed might have been planted then, and it's starting to truly flower now. So that was a lot of academic and kind of online research. When we moved to Colorado, even just for those few months to kind of figure out where we might move more longer term, by chance, I met the gentleman at Rocky Mountain Hemp Company, and they invited me to help them on a backyard build. They were building a small DJ booth for the backyard and experimenting with different binders, different herd. And for me, it was a great experience to be able to get my hands dirty and ask lots of questions. But because they were experimenting, it made it obvious to me that they were very much still in kind of research and learning mode. And so I decided, for me, the next step in my own education was to go out to Idaho to go study with Hempitecture, who at that point were one of the most recognized leaders in the space. And so this is Maddie Mead in the center there, and we spent it was 3 afternoons because we had lectures in the morning and then building in the afternoon. But basically, a full day and a half with several of us in a shop environment building a small section of wall, and we were both all very excited and exhausted. And I thought this is amazing for community-based projects or projects where you want to bring people together, but I didn't see it scaling at the level of being able to get to the point where we might truly start to live up to some of those carbon reductions that we're talking about. So kind of reality check there, but still, as I looked at this, to me, I saw hempcrete at the intersection of lots of different facets of the kind of overall conversation around sustainability. So I was saying the Joseph Allen book talking about cognitive performance and on the one hand, and healthy air exchanges, healthy buildings, but also regenerative architecture. The Living Future Institute talks a lot about that. That's been something that's been advocated. Buildings that give back to the grid or to the environment in some way. People talking about deep green architecture, pushing the envelope in terms of innovation, and of course social justice, which I mentioned before. There are other ways, it just kept different facets of this continued to kind of expand for me. So talking about you guys are in Ventura or Southern California overall, to me the conversation around farm to table food, that was, going to the farmer and the cook in Ojai, that was a real treat for me. And I've often thought, well, farm to table architecture, as we get kind of more sophisticated about our understanding of wellness development, that these things all come together. And so I often use those as metaphors for people to help understand. But when we're talking about buildings, we want to also move from metaphor to real performance. So again, talking about regenerative buildings and using solar panels and building materials that are made out of extractive processes didn't quite jive. There was some cognitive dissonance there. And so I thought, really, it's not just hempcrete, it's or hemp as a material, but more a kind of larger conversation about making the shift towards bio-based materials. When I gave this presentation the second time, it was to the American Institute of Architects in Santa Fe. We had local monthly chapter meetings, and I thought, well, if they're in Santa Fe, the Architecture 2030 is, of course, based in Santa Fe. And so I'll use some of the data there to be able to make the larger case about why this makes sense, right? Buildings use roughly 40% of the global emissions. And if we're really going to make a difference, then we need to reduce that. And it's not just about energy efficiency, like kind of the light blue, the 28% there, but the interesting thing, or more interesting thing for me about the graph on the right, was that as we move forward, as energy codes get more and more stringent, the building operations will become a far less important aspect of this, and then building materials become the next hurdle that we have to really start to tackle. So I thought, well, hemp, let's start to look at you know, a lot of materials that are in the built environment, and you can see that metals, plastics are at the top, and natural materials near the bottom. You know, so less and less embodied energy in the straw, stone, concrete. Well, I don't know why concrete's in there, but bricks. And when I gave the presentation, not a single person in the room had heard of Hempcrete, but I had done a little bit of research prior to standing in front of everyone. And of course, if we look at the page 10 steps to reducing embodied carbon, hemp insulation right there. And so I thought, you know, the building technique is out there, but part of the effort that we need to do is educate our own, you know, colleagues as well as clients, people who can help accelerate this movement. So Chris talked a little bit about CO2 overall as a material. There's and we talked about the challenge of gathering more data. What I found, one of the lower, on the lower end, maybe 6 tons of CO2 per acre, but as much as 54 tons of carbon per acre in some studies. So just to put that into comparison, US EPA has found that the typical 22 mile per hour gallon gas-based car emits about 4.5 tons of carbon dioxide per year. So 1 acre is the equivalent of more than an entire car per year. And then Hempcrete is, you know, it's a mixture of lime and herd, so not just the hemp, right? But if we look at Hempcrete, it's still considered, this is another Architecture 2030 graph. Hempcrete still comes in as a carbon negative material. And if we compare that to the petrochemical based products at the top, EPS, high performance material, but with a large carbon impact. So trying to find that balance, the happy medium between performance for the building and performance for the planet is when, you know, I think a lot of us start to say, hey, listen, we should find ways to balance that or even offset it. Between several different iterations of presenting this, I came across an article that talked about how proposing a kind of nomenclature, a way of talking about different forms of aluminum, right? If I don't know how many architects are in the room here, but when we look at specifications, we start talking about whether we want high recycled content or we want different facets of a material or an assembly to be selected. And so this guy was Lloyd Alter from Tree Hugger talking about dark brown aluminum, say aluminum that was made with coal-fired electricity versus aluminum that might have been recycled content or high post-consumer recycled content, or aluminum that's been produced with hydroelectric power. And so I thought, well, okay, this thinking about reduced energy is starting to take hold, and it's going to change the entire market. But for me, I still was kind of basically sold on the idea of natural materials and bio-based materials overall. So if we're going to start to take a look at how we might take this kind of thinking and look at the average house, Chris Magwood did an amazing study for the city of Vancouver up in Canada, looking at different parts of a home, and you can tell that concrete is roughly a third of the embodied carbon of a typical house up there. If you don't have a basement, or you're on you have a raised wood floor foundation, then your concrete would be far less. But this was the average up there, and I thought it was fascinating to see that insulation was still counting as roughly 21% of the embodied energy. And since you guys have seen the previous slides, you know that if we're switching this to either hemp wool or hempcrete, another bio-based material that could be carbon negative, like straw bale, that 21% can actually be reduced to a negative number and start to reduce the overall carbon profile of a house here in 2024, long before we've even reached 2030. But of course, it affects also interior surfaces, cladding, framing can, in some cases, can be reduced if we switch to advanced framing techniques. And so starting to use these feedback loops to be able to understand how to get towards carbon zero, if that's even possible. So the slide on the left, or the image on the left, was what I would call an advanced building assembly when I was learning how to build in this way. If we were working on institutional projects, putting insulation on the exterior to be able to reduce thermal bridging between the 2x6s was seen as a major win and advancement for the way that we were building. And so when I saw that a typical cast-in-place wall assembly had the wooden frame embedded within the hempcrete, I saw that roughly 2 inches on either side of the framing as a similar kind of move to be able to protect the wooden frame, which is great for insects like termites and things like that, but also for fire resistance. The other thing that was fascinating to me when putting this together, of course, over the last few years, the supply chain shortages, the labor shortages in the construction industry were suggesting to me that simpler forms of construction were just made more sense in many cases. Another part of asking the question, is this material sustainable, is the question about how far it's coming from. I should have done an adjusted circle for this presentation, but this was a 500-mile radius circle from Santa Fe. You can see it encompasses a good amount of Arizona, where I am now, Texas, Colorado, Kansas, where there's a fair amount of hemp growing. And so if we think about say the lead material regional credit, either 500 miles as a radius for trucking or 1,000 miles for rail, it covers a large part of the United States. And so, kind of another touch point for me to say this is reinforcing my idea that this makes sense as a building material. So this is some examples here, just to move out of data and graphs and back into pretty pictures. These are the interior photos of the Martens van Kelmier project in Belgium. I think, a lot of people think green materials might start looking like a hippie house, but to me, this is a very modern, clean aesthetic. It looked like a house that I would love to live in. And the clay straw fields, or strawberry fields project in England that was on the first cover slide was also part of a community development. So there's agricultural growing, playing fields for the kids. And so the idea was truly healthy people, healthy planet. And I just love the way that they integrated the two. For any lovers of design, you've probably seen this project before. This is Margent Farm, group called Practice Architecture in England. They built this house out of the client brief said basically to build the house with as many materials on the farm as possible. And so the main insulation value was achieved with cast in place hempcrete. And then on the exterior, they created a special hemp resin based exterior cladding. So it kind of looks like corrugated, almost a rusty corrugated metal, but that's a hemp bioplastic, hemp resin. And then I said earlier that a lot of hempcrete really originates, as far as I'm concerned, from France in the 80s. And so you can imagine France has been one of the real leaders in this space. This is a firm called Lemoal. And well, you can see the exposed wooden beams there. The actual envelope is built with hempcrete blocks. This is some images of the Cape Cod hemp house. This is just completed last year. This was a spray applied technique. So we talked about cast in place, we talked about blocks. Spray applied, in my opinion, is probably the technique which this really starts to scale. In different environments, blocks or panel systems may be more appropriate, but this is Laurent Godet spraying the exterior there. Really, I think the spray piece went by really quickly. And Cameron McIntosh, that I mentioned before, has told me that he can spray a house of roughly 2,000 square feet in just a few days. So the question then, in my mind, becomes what technique aligns best with the type of project that you're looking for? So in Southern Colorado, there's a gentleman, Arnie Valdez, really neat guy. He's a Harvard Leb Fellow, someone who taught alternative building materials at the University of New Mexico for many years, but also a farmer. And so, and of course, very much appreciating the tradition of Adobe in the region. And so he's been experimenting with hemp mixed in with Adobe bricks to be able to give it a little bit more cohesion, and he calls them adobes. So that's the kind of super low-tech version. This is probably one of the most influential projects in the US so far, primarily because it brought so many different people together. The Parsons School of Design, the Healthy Materials Lab, Penn State, nonprofit developer Dawn Enterprises. A lot of people came together so that what was being talked about seemed very abstract, building with hemp, became very tangible and very real. And it's been to me, not just a great example of a project done well, but also an example of a pilot project, which I think I've been advocating for in many different cases. And so if we've been talking largely about hempcrete, or either in the form of bricks or spray applied, there is also hemp wool, and this is made by the group out in Idaho, Hempitecture. There's several different manufacturers that make hemp wool now, and someone just joining now. But there's also different ways of using hemp as a building material. One of the most successful of which is coming out of Kentucky, hemp wood, which is actually harder than I think it's harder than oak and mahogany and some of the real hardwoods. Very impressive. And I've talked to Greg quite a few times, and I'm really interested that his story is similar to mine in that he had health issues. He was in the bamboo flooring industry and had, was suffering because of the formaldehyde that he was working over in China. And so when he decided to come back to the US, he decided he was going to make a non-toxic material. And so Columbia Pure Bond is the backing for that. So an engineered plywood that has no formaldehyde. They use a soybean-based adhesive, and pretty amazing. And then some of the block examples. There was a group in Canada. I don't think they're still in business, but they had a system which basically huge Legos, just biofiber. They had ICC and ASTM testing completed, but problems with the business for whatever reason to be able to scale. And then if we're talking about blocks, one of the largest manufacturers in Europe is called Hemp in Belgium. So we saw a little bit on the kind of updated cover that I shared with you guys. This is the Hillside Center for Sustainable Living. This was, they switched to cast in place tilt-up or spray applied tilt-up after phase one. So phase one was insulated concrete forms. And during that process, Hall and Moskowitz looked at the, they've been obviously reading all this kind of press about concrete and saying, is there a better way to build a highly insulating home without using the concrete? And what they arrived at was these big tilt-up panels for the exterior envelope. And when I first gave this presentation, as I said, to the University of New Mexico, I thought, well, the students are going to want to see something that's also forward-thinking. And I thought, well, everyone's talking about 3D printing. Maybe I can find an example that would be close, that we could start to imagine 3D printing with Hempcrete. And so this is Tekla's project. It's an acronym, technology plus clay. And I think it was only just a few months after I shared this slide that I saw that Texas A&M had received a nearly $4 million grant for 3D printing with Hempcrete. And so we're a few years along on that grant. I would love to see hear what they're up to, but I guess it's top secrets for now still. And as we kind of back out, to me, the larger conversation is not necessarily just about hemp, although that's the focus really of the conversation here. But if we think about the larger move that we all want to see, kind of the construction industry providing better alternatives to deal with carbon reduction. This is a project in down in the Green School at Bali in Indonesia. Obviously, bamboo, rapidly renewable, non-toxic material. It's incredibly flexible, so they're able to create amazing shapes out of it. And then closer to home here in Arizona, there's a studio called Dust Design Build. It's continuing the rammed earth tradition that Rick Joy and others have been building with here in Tucson for a while now. So again, non-toxic, natural materials, but of a totally different materiality. So that's the bulk of the presentation. And then I do want to share with you that also have created a kind of single one-pager, an executive summary. I'm happy to share this if you guys are interested, but to talk to policy folks, to talk to building officials, to just in a single page kind of go through the outline of what is Hempcrete. So a bio-based construction material gaining traction through innovation. Obviously also policy change, right? This doesn't happen without the Farm Bill, and now is accelerating with the adoption of the International Residential Code. So what is in Hempcrete? Again, we talked about this lime, pozzolanic, or cementitious binders, depending on the mix and the application, hemp hurd and water. And then in terms of sustainable architecture and buildings, we can say low embodied energy material, because the lime production, the lime piece of the chemistry does have embodied energy, of course. And so it's people talk about it balancing out over time through the curing process. There was a question earlier about insulation value. One of the projects that I'm working on now in New Orleans, the gentleman who produced the panels had done a test that received a value of about 1.9798, something like that. So a little bit on the lower end. I think most people would say, R2 to R2.2. And so in the frame of reference that I was talking about, roughly 10 times the insulating value of Adobe, but a third as much as polyiso cyanurate or blue board. So a kind of happy medium. I won't go through the rest of this, but this is something that I think is helpful when we just present things in a very clear and kind of digestible manner for people who are new to this. So yeah, that's about it for today.
That's great, Alex. Thank you. Yeah, and I'll be sharing slides with everybody afterward. So yeah, if you just send those to me, I'll be sure to send those out in our follow-up email.
Sure.
Any questions out there for Alex? I see we have one in the chat. We'll start with there. Does Hempcrete meet seismic needs in places like Northern California?
So the if we're thinking about Hempcrete as the insulation, we wouldn't really be asking it to handle the seismic aspect of things, right? So what we're really talking about is how do you handle the lateral forces when it looks like you want nothing in between. And so people have been using metal strapping, so diagonal bracing that's out of metal and should be hot dipped galvanized. Otherwise, there is some galvanic action that you need to worry about. But some of the I've seen beautiful projects in Northern California and Oregon where they had stunning diagonal bracing made out of it looked like 2x6s to create that lateral resistance. Do you know of any passive house certified projects using hemp? Short answer, no, I don't. I think there was some kind of tension between the world of passive house and the Hempcrete folks, because we look at the kind of reduction of toxic materials as something that's really pretty important. I guess I should specify or preface that by saying there's lots of different people who are coming into the space of Hempcrete for different reasons. I shared with you guys that for me it was about research after dealing with mold, but people who are coming into the world of low carbon, high performance buildings also looking at that. So passive house, they're interested in super insulating and really tight envelopes for the for the overall building. And to do that, you're kind of going against the philosophy about we would say colloquially breathability, but what we really mean is vapor permeability for the envelope. And so there was some kind of back and forth between the passive house types and the Hempcrete types. But I have seen data. There's only one house that I've seen in Europe where they were able to get down to, I forget what it is, 0.5 or 0.6 ACH, which is to say to meet passive house standards. And so I don't think the two are incompatible. I just think that they're two different philosophies. And in fact, one of the things that I've been trying to do is reach out to different adjacent groups. I don't think I mentioned that I'm on the board of the U.S. Hemp Building Association, but I am. And one of the things that we've been doing is reaching out to groups like the Green Building Council and Carbon Leadership Forum and trying to get what is, for many people, a high-level conversation to a very specific material and saying, here's a great example of one that we can build with now. I would say, yes. So to better understand, it does not really have a structural component. There is, as far as I know, Tyson, there is a study from Queen's University in Canada that showed that a hempcrete, let's see, a wooden frame cast around hempcrete was more rigid because it was because of the hempcrete. So it's possible to say that there is that it can reinforce a regular structure, but typically we're not approaching it as a structural material at all. So no. And then there was another question up above. Would you say hemp lines up better with living building challenge philosophy? I would say yes. And I was a little disappointed. I made a proposal to speak at the Living Future conference this year. And for me, a lot of the conversation that they've been having recently is around environmental justice and social justice as related to sustainability, that's a really important feature of this. And to me, hemp checks all those boxes. And I think, I don't know, I'm just not famous enough yet, or they weren't quite ready to talk about hemp. They are willing to talk about bio-based materials. And this is the interesting thing that I've found is that people will talk about climate smart materials. They'll talk about low carbon, high performance. They'll use lots of different words, biogenic. But if you use the word hemp, you might very well turn people off. To me, I look at hemp and straw as two of the leading contenders for making huge reductions in carbon right now, because it's been tested in Europe for at least, Hempcrete at least 40 years now. And none of the other materials that I see coming out yet have that same kind of track record. For me, you start thinking about warranties, you think about longevity. That's an important part of this. Are there hemp insulated boards? Let's see. I think I can say yes to that. When I was out at in Ketchum, Idaho, at Hemptecture shop, I talked about exterior insulation with them, and they said, "Yeah, we're working on it." And I think that's actually been announced now. I think that's on their website. You could use on the exterior of a mass timber building. So one example that I didn't show that has gotten a fair amount of attention was the Urban Sequoia project from Skidmore, Owings and Merrill. Huge corporate firm that's been in business for, I think since roughly 100 years now. They put out a vision of a sustainable residential tower, and it had mass timber as the structure and hempcrete and other sustainable materials for the interior of the building. So, and I know Hemptecture has gone out to the Mass Timber Conference. To me, it's a natural ally. You have, I would say Master Timber is probably the poster child of the bio-based movement to shift to higher technology, better performance, and a real story around carbon sequestration compared to steel and concrete. And so to me, straw and hemp are the next two on. Megan, Hempblock USA is not load bearing enough. I know the name Hempblock USA, and I've seen the blocks, the kind of tongue and groove system where they lock in like that. I haven't really looked carefully at them, but every other block that I'm aware of is not load bearing, and so I'd be very curious how they achieve that. And I think the question that we asked earlier about seismic nature would suggest taking a closer look at that for use in California. I would be cautious on that end. So I want to make sure we've got enough time for Ashley to give his presentation, but hopefully I shared something of value for you guys today, and really appreciate the opportunity to speak.
Perfect. Yeah, thank you so much, Alex. I think that was a great overview between embodied carbon and some awesome design considerations and examples. With that, we'll have Ashley join us and round things out for this evening. Thank you.
Hi, good afternoon. Good evening. Is everybody there? Can you hear me?
Yep, loud and clear.
Awesome sauce. My name is Ashley Stallworth, and I am currently positioned in the Pacific Northwest up in Washington State. Also, most of you will know that is where Bigfoot hangs out, and he definitely likes to hang out in big patches of hemp. And occasionally he comes through and helps us with the processing, but don't tell anybody. So Our company, I proudly lead a company called Biofiber Industries. We've been in the processing, manufacturing space and distribution since 2019. We were one of those early R&D groups that benefited from the 2014 Farm Bill, where we had seed stock where we can go up to Canada, right, and get seed from a locker and go plant it and see what it was like, right? Obviously, in a state that is highly on the THC side, it was one of those little known crops that had a lot of favor that has now grown and risen to the top. So I'm very thankful to be here today. Thank you to Alex Sexsmith as well as Christopher Velasco, and a big shout out to Amanda Martin with Renewal Revolution for helping to make this happen. I also proudly lead a 501c3 group called Minority Hemp Builders Association, which helps for builds. So let's get into this. First things first, everybody on this call, I'm wondering if you've thanked a farmer lately. That's my question to you, right? Because I wake up every day and I realize how important it is. I became a farmer. I grew up around them, but every day I realize we need to give a lot of credit to the farmers, because without farming, there's no processing. And without processing, there's no material to build with, right? So there's a couple fundamental areas that we have going on, and I just want to make sure that that's pretty clear. Everybody plays a really important part in this, as well as getting it into the ground, all the way down to processing, to getting this into healthy homes. So what we've learned throughout the journey is that processing empowers healthy homes, buildings, and products. By offering carbon neutral materials for new construction, remodels, restorations, industrial industries, and consumers, we all can win, right? We all know that there's something better here. There's greener products. There's history tied to this, and we'll get into that a little bit. To give you a little bit of background, just so that you can realize that that we're accredited in a sense, our areas of experience stem from farming, right? From farming, we realized that there was limited processing, so we had to develop it ourselves, as well as travel around the world to find out exactly what were the best methods, tools, and things. Now, we won't be able to get all into that today because we'd be here probably for about 2 hours, but I'm going to try to get through as much as we can, and that's for sure. We also have experience in material supply, manufacturing of finished products, and export. Believe it or not, a lot of people want what we have here in the U.S. Green things we'll talk about today. We're going to talk about processing hemp stalks for hemp hurd, also known as shiv, to be used in hemp lime construction. We're going to talk about transforming hemp into non-woven fibers, which are also relational to construction. We're going to talk lightly on environmental and economic impact, and also briefly on the future outlook and technological innovations within the space, because there's a lot of them. So this right here, I'm sure you all are familiar. It's a stalk, right? This comes from a plant which you get chopped down. These things can grow ginormous, really thick in circumference and diameter, or they can grow really thin. Really depends on your region. And we'll talk about some of the history around that as well. From that stalk, you can see it gets broken up into a couple primary fractions. All right, here's a little bit of a zoom up so you can see once you crack that thing open, there's more stuff inside as well as on the outside. But for this, right, a lot of the building materials right now that have IRC and ICC acceptance, right, it's like what our mom says. It's what's on the inside that counts. Here's another look at it. Just want everybody to have some good visuals. And it's hemp. So as we dig into this, we all know that there's many modern uses for hemp, right? As a process manufacturer, we are tasked with breaking these stalks, stems, into multiple fractions, right? That can serve multiple industries. Our mission, and what we think is the most important, is the built environment. We know that there's a lot of other areas that people can definitely become really inspired to navigate, to lead. And it's been very fortunate for us that we've been able to provide for these areas as well, right? So I just want to make it know that, hey, there is more to this plant, but for this specific presentation, let's focus on building. There's I and our team dog in the field, one of our fields. This right here, we grew it. This was a 2022 photo. These ones were still about another month out. They grew up, ended up being the tallest plants in the state. But after you grow them and they look great, you walk through the fields, what do you do with them, right? How do we get them from the farm to the processing station, right? And that comes in the form of baling, right? Baling is a really huge thing for us, right? When we take in inventory, mass, and it comes in different forms because each farmer or aspiring farmer finds himself in a position of, how are we going to harvest this? How are we going to cut this down? How are we going to bale it? How do we make sure it stays dry? How do we make sure it stays safe? All right. So these three techniques are the most widely used: round baling, square baling, and shock bundling. Shock bundling stems from thousands of years. I mean, you still have people in Asia, the Middle East, who still harvest like this. It's manual labor. There's a lot of manual labor to this, right? Process and getting stuff that's automated is great. We've been able to achieve a lot of that, but it still requires some grit. I will not hide that from you. It's not for the meek. It's not always clean. It does get dirty, but it's fun. So the traditional method of bundling hemp together by hand and it's standing up to dry is often referred to as shock bundling. I said, this is the method where they harvest, they gather it into bundles by hand, and they stand it upright, right? They lean it up against each other, creating almost like a pyramid effect, right? And this allows the air to circulate around the stalks, facilitating the drying process. We've done this generally on a lot of farms. We have a lot of aspiring farmers that are usually about 15 acres or less, right? If they don't have the equipment, right, or if they don't have the manpower, the dollars to hire somebody to come in and harvest with a square baler or a round baler, we usually say, hey, go out there with a sickle and go do it yourself. Now, if you're farming on, anywhere between, 15 and up, that's when you're probably going to want some bigger equipment, to be frank. But there are definitely people in regions right now that are farming hundreds of acres by hands. Square bales, we've all seen these, right? These work really, really well, right? It's really traditional. A lot of this farm equipment is out there, easy transferable to this, right? This is something that we get a lot of farmers saying, well, hey, can I just use my square baler? Can we do that and just get it going? I'm like, yeah, hell yeah, you can. You absolutely can. It makes it a lot easier, right? It makes it more readily available and easier to access compared to round balers in some regions. Round bales, now these are like the godsend, right? You see people doing moisture wrapping on these. This is where you can get some of the most tonnage. There are some huge square bales, right? But the round bales can carry a little bit more. These are like, anywhere between 2 to 4 tons. That's a lot of material. There's some people that have even larger sizes. And, usually the square bales are anywhere between 200 pounds, maybe up to a ton, right? Those are some really big ones. And you get a little bit more traditional farmers to do that. So some of the harvesting techniques, and we're going to get into the processing, but it's super important to understand that these techniques impact our workflow and anybody else that's in the processing space, right? It's imperative for people to understand the timing, right? When they're going to be able to reach the stock at its maturity, right? That's going to fit the workflow of the equipment that they have, right? So it's usually about 60 to 70% maturity rate. That's what we found. Obviously, if you want to be amazed and see how tall these things can grow, you can let them go and they'll go up to 20 plus feet, But one of the base things, just like we see throughout history of the sickle bar mowers, right? Much like somebody with a sickle bar, right? Can cut these things right down, right? And there's been some really great achievements in the field. I'll share one of the companies that has innovated big time, right? There's other innovators out there, right? And I believe the USDA is working on innovating as well, right? So that they have something to be able to give back, not just use all the, the Canadians, some of the South American IP. We got to have some here in America. You can use silage choppers, right? Silage choppers is a really great way to get that material out of the field fast, right? And deliver it to us, the processor, right? And we get to classify it. Now, one of the big things that we're going to hear is like, fiber and grain. Fiber and grain go hand in hand because a lot of the adhesives, a lot of the stuff that's going to be going into construction, right, you can get from the seed as well, right? So the seed and fiber are very, very close together, and you need a dual purpose combine harvester to be able to do that. Now, if you've ever seen a dual purpose harvester, they're huge, right? And they cost a lot of money, right? Which is cool. It's a big toy. Love them, right? But it's just may not be available for everybody. Right. So here's some images of them. You've probably seen them. A little bit crude, right? It's a farmer's dream, right? Let me tell you, right? RoboBank knows people are showing up trying to get those loans because not everybody's liquid cash on these ones. For real, for real. So, the modified carbine harvesters are definitely in queue, right? We have traditional looking sets, but we're going to be moving forward in this area because we know that this crop on a macro can be worth the investment, right? So look to your conservation districts, look to your Department of Commerce, right? These are adjusted dollars that are going to be going in those areas. Like I shared before, the sickle mowers and the silage choppers. Just want to give you some light visuals in case you haven't seen what any of this equipment looks like. If you have any more questions, always feel free to reach out to us. Now on to the fun part, processing, right? This is where we get to mix it up and see what's what. So as we dig into this, I got to give some history, right? This photo right here is from 18th century. We've found even older ones, but they're in much cruder condition. Hemp decortication technology dates back to thousands of years, with evidence of its use in ancient civilizations such as China, Egypt, and India. Some of the oldest buildings in the world are thousands of years. There's temples in India right now that have this material mixed in there. There's no moisture, there's no bugs. They use it in their artwork, right? They use it in their walls, in their mortar mix, right? This includes the Greeks, the Romans, right? We as a team had to go and travel the world to confirm. So it didn't sound like we were just making shit up, to be quite frank, right? So it's very, very real. The traditional Chinese hemp decortication used in the 2nd century, right? They use a stone roller crusher, right, to crush the stalks and scrape off the woody core. It's a very labor-intensive method that produced high-quality fiber. And if you see this right here, which I'm circling around, this right here is your key to freedom, my friends. The roller crusher. This right here has been modified so many times. I mean, you've had companies that try to patent this even during the phase of America where it was illegal. So just keep that in mind, right? This is old, ancient technology that we keep refurbishing, right, and doing a certain way. So in the 5th and 18th century, right, medieval Europe, hemp was vital for making ropes, sails, clothing. The traditional decortication process involved water retting stalks and then beating them with mallets to separate the herd, which was also labor intensive. Now, when we talk about this area on the academic side, it's important to know that Europeans started processing because they wanted to beat the empire that was coming out of Asia, right? They managed to get a hold of their seed stock, grow it, and process it down. So they used a lot of the technology that came out of Asia, right? And on a genetic level, when it comes to the fiber strains, Asia started growing specific strains that wouldn't provide seeds because obviously they didn't want Napoleon and all these other folks, right, to be able to keep copying them, right? They didn't want them to win the war that they eventually felt was coming, right? A lot of cool books on that, a lot of cool history, a lot of good stuff to geek out on, right? And you got to dig deep because some of this stuff is out of print, my friends. It's out of print. I've had to go to Michigan State College to even find some of this stuff. Literally open up wooden boxes with dust. Right, good thing there's no SARS, and it was a little bit before COVID, so none of that stuff. So in the 1900s, here we are, United States ran several decorticating plants, right? Even families that were tied to the DuPonts and I love the Dow family, which is really tied to the NASDAQ Dow. Now, I won't go on to that. I could, but if you want more, like I said, reach out. Right. So these plants were up and running. I've seen them. Also, there's a couple of old factories that you can still find up in New York, upstate New York, especially in the Hudson Valley. Hudson Valley was a huge producer. I lived there, as well as in Paterson, New Jersey, which is the oldest manufacturing port city in the United States. And they have water galleys. They have a lot of the framework of what I just talked about right here. So from the 1990s to present time, right, the use of traditional roller crusher systems has become standard practice with many modern advancements, right? Now, I think some of you on here are going to know, yeah, all right, roller crushers, that's cool. What about the hammer mills? Like there's a general list of hardware that you'll find yourself saying like, hey, can I use this? Maybe. I'm going to tell you, we've broken a lot of machines, right? We thought we were slick. We tried to do the wood chippers. Works so much, right? There's a lot of ways to kind of get it, but this is industrial here. So processing requirements, right? This is something that we talk to all the farmers before they bring it in, right? Don't let it be moldy, right? Because we're going to call you out, right? We're going to have to send it back out, and you're going to have to open that thing up and then feed us back the material that's not moldy, right? Because mold is a hazard, right? Even if you UV it, right, you're still going to have some slight issues, but that's a whole nother topic on the quality assurance side, which anybody that's process manufacturing should know. It's also good to have in your GMP guide, right, as a process and a standard order procedure. Check the moisture levels. Like most hay bales, right, you're going to want it to be anywhere between, 10 to 13%, right? There is some new technology where it's shockwave pulse processing, excuse me, that can now kind of knock that out. I've only seen that twice. There's some Texas folks who are working on some really cool stuff. I think we're going to hear about it, but it's also IP, right? So people can get a little bit restrictive on that, especially since they put a lot of time in. Also logistics, right? Knowing how you're actually going to be getting this material, right? How long it's going to take, gas, mileage, right? These are all factors that, the farmer to dispatchers, they're going to be up in your ear about. They want to know what's going on. They want to know the price. Gas is everything, right? And we've been hurtling over gas hikes and inflation over the past couple of years. So it's been definitely an impacting factor. And then I always say have a backup plan for a backup plan, right? Because, with processing lines, right, sometimes you don't want things to break and create redundancy, right? Because then when you have orders, right, and you tell somebody, hey, I'm not able to get this material out to you, right, they're going to look at you like you're crazy, right? And then you start feeling like you may be crazy, but you're crazy because you're telling the truth. So, what are you going to do? So this is on the logistics side. We wanted to provide an example to give you a little bit of a map so we could show how we do things in Washington State right now. Washington State requires a grow license as well as a processing license. We are the first minority-owned hemp fiber processor in the United States, right? And as well as for the state. Everybody else went more on the cannabinoid side, right? Especially a lot of those farmers who are relational to hops. So if you can tell, we have an I-5 corridor here, which is really huge for us because it allows us to connect to some of the larger agro parts of our state. The cool thing about Washington is that we are historically an agricultural state, right? So even if you're on the west side of the state and you're growing 50 acres or less, you still have a place to take it. I grew up in a little town up here called Savannah, where my grandmother ran a grain and fiber processing company, right? Tallest mill in the town of 70, right? Only eclipsing the meat market across the street, right? So fiber and grain was kind of second nature. So we always knew the stuff as Indian hip. So once my friends started smoking the other side, I noticed that there were always stems and sticks left over. And I was like, hey, what are you doing with those? That's, that's valuable, right? So the decortication process, right? There are a lot of different ways to show this. I wanted to be respectful of some of the people in the field's equipment. So I thought it was appropriate to show a diagram, right, of what this looks like, right? So the purpose of the decortication line in general is, it's essential for separating valuable fibers from the herd, right? The primary component in hemp lime, which is what we're talking about today for building materials primarily, right? The one that's got the ICC, the IRC approval, the one that is pretty much our freedom flag in this moment, as we also qualify in other areas because there's ways to get to that, as Alex and Christopher had alluded to earlier. The mechanical decortication techniques, right, are primarily run through by roller decorticators, right? Those roller crushers, right? Which break the stalks between the rollers and they effectively separate the herd from the fibers, right? Now, some of these systems, right, you'll notice like there's two of them in this system. Some run with one, some run with two. It's really going to depend on the budget. Also, hammer mills. Once you do a first pass, a lot of the time, unless you have a robust system, which I'll show you the prima donna. But if you don't, right, you may need to do a second pass, right? We still do second passes to assure quality, right? That we're getting the dust out, that we're creating something that Americans at this point in time want and desire to be the European standard. What we believe is that people are going to learn that the European standard is very limited and it is not the primo, right? There's people in South America and Asia who process a little bit more crude, still get great material, right? Viable, a much lower cost, and able to get it to market. So I won't read all this, but as many of you know, there's a lot of versatility when it comes to hemp fiber, right? And we're talking about the short fiber as well as the long fiber applications, right? We know that it's fast growing, It's a sustainable material, right? It has strengths and durability. It's eco-friendly, right? And it can go into many different product areas, right? But for the building focus, right? We're saying paper products, we're saying non-woven textiles, we're saying building materials, right? These are things that are all facets of homes, commercial buildings, structures. You go to parks, it's a part of it. You know what I'm saying? So on the long fiber, right? You were talking about more about textiles, automotive parts, and ropes and cordage, right? Which in a way still is relational to building because you still have to build these things. So let's get into the fractions that come through the decortication process, right? First one is herd, or you heard, right? Get a little real urban when I go to the city, so I try to make it sound cool, especially for the up and coming workforce. Herd is essentially the same as shiv, right? A little bit different, but more or less the same, right? Or the inner core of the hemp stalk consisting of woody fibrous material rich in cellulose and lignin, right? Almost every hemp talk you go to, you're going to hear somebody who says it very passionate because it's awesome. It really is, right? So on the processing side, the herd is typically separated from the long fibers during the processing and undergoes further refining to remove impurities and achieve the desired particle size, right? Now, this can be done by shredding, silage, hammer mill, right? As I talked about before, and we've done all of them, right? We're like, how do we get the best? In the beginning, right, we realized like a lot of people wouldn't buy it unless it looked like Snow White perfect, like the Europeans were pumping out, right? And this, in our opinion, slowed down the industry because when you first do a first pass, like the image appear on the screen, it doesn't look beautifully bleached. It doesn't look beautiful, like it. This is raw material that can still be used. We use material like this on builds right now, and it comes out same R value, all the things, right? Now, let's get into the sizing, right? Desired herd sizing for hemp line building materials, right? The specifications, we found that anywhere up to 3/4 of an inch, right, is optimal for hemp line, right? It affects the material's compaction as well as the insulation properties, right? Processing techniques. Now, this is where things get changed up a little bit, right? On your process assembly line, right? You're gonna want to add screening, right? It's mechanical screens that sorts the herd into desired size ranges for consistency, right? And you can find yourself creating essentially different SKUs, right? Like not all sizes are the same. Some people get very pedantic and they're like, I only want 1/8 of an inch. I only want 1/2 of an inch. I only want 3/4 of an inch, right? And they can go around and around and around. But what we found is like, hey, if we screen it a certain way, we'll be able to deliver for whatever they want, right? Whatever you want, right? To essentially power healthier materials actually getting to market, right? So we tried to not get caught up in saying, hey, one size fits all, right? Because when you mill this, it doesn't all break up into one size, right? There is no perfection here, right? I think that's much like whether it's, earth homes or a lot of different styles, right? Like there is a level of where you're saying, hey, there's a natural thing going on here, right? And I think that's what we're stepping back into in history. So there is some additional information here on the milling side, right? Where you can mill it down, take a screenshot. Definitely, these are live images that we took from this was our first round, 2019, that we did, where we were fortunate to go into Montana because we were just growing at such a small scale in Washington. We wanted to go bigger, and we were able to go into Montana and grow with a group called the Hooterites. Now, I'm not sure if anybody's ever heard of the Hooterites, but they're kind of like the Amish. Very cool, farm for Frito-Lay. They were like, hey, let's try it out. It was, they even had words of hemp that stemmed all the way to their Bible, their version of the Bible, which is kind of wild in a sense. And, so I was able to speak the good word for all those who care. My dad was a deacon. His grandfather was a deacon, or his father was a deacon, his grandfather. So, I'm definitely a man of faith, so to speak. So with that being said, this is showing particle sizes in hemp construction, right? The blocks we find are really good. The infill tamp is good. Spray is good, right? But they all require pretty much the same increments, right? So there is, as Alex had shared before, there's going to be preferred ways to be able to integrate. We've heard almost every single one, all the way to the 3D printing, which we have a company up here in Washington that's doing some very, very cool, remarkable things. And that brings it down to an aggregate. I'll have an image earlier where you'll see what a lot of that aggregate looks like, right, from some of our early testing, right, before we realize, like, hey, we need to just do a better job at screening. So short fibers, right? So along the line, while we're also processing with a focus on the construction, right? This material is as well relational, right? This is also known as the tow fiber, right? Which are shorter strands of hemp fiber, which are extracted during the processing. They typically measure a few centimeters to several inches in length. For processing this, right, the short fibers are often separated during the initial stage of processing, such as decorticating or scutching table, right? Definitely a keyword. Scutching tables can save you a lot of time. It's an extra piece of equipment, but it is. And you see a lot of this in the realm of other fibers type of materials, including cotton, wool, things like that, right? Where the long fibers are separated, right? And they're able to kind of grab them out there, little hands, little nails going at each other. The value to industries for the short fibers, right, which we talked about before, is usually the textile industries, right? Anywhere from spinning yarns, weaving fabrics, producing non-woven textiles, etc. And one of the main competitors of this industry right now would be rock wool, right? Rock wool, if you know rock wool, right? Crazy process of going in, but ultimately they're spinning, right? Like at the end of it, after all that labor, heat, clashing of materials, they spin it, right? So there's an opportunity for us to use this, right? Which we have some great companies in the field right now, which we'll share, who are doing this, who've been able to figure out, hey, well, if we weave or if we bind this material with something else, or if we use it, we can do something that is much less carbon intensive, right? And bring more value for the home. So when we go from short fiber, we go to long fiber, right? And, you know, the long bast fibers, right, which we call them, are collected as they're separated, much again, from the hurd and the bark by the roller crusher. They undergo further cleaning to remove any remaining impurities, such as dust, dirt, and residual hurd fragments, right? This is where you get that real long strings, you know, and can do some really cool stuff, right? We're going to start seeing more hemp jeans and other types of really cool stuff, right? As well as materials that can be used within the housing market, right? So this is going to become part of the built environment as well. And that's what we've been really excited to see, especially with some of our clients that have been coming through. You know, they've got great visions. A lot of them come from industries that are directly across the line, right? They're just doing it in a more carbon intensive way, right? So quality control, right, is a really huge portion of this, right? So throughout the process, right, we're ensuring that the extracted fibers meet the required standards for length, strength, and cleanliness. As a processor, right, especially when you have a client, you want to make sure that these expectations are clear, right? It's very, very important, right, on a business acumen level and just on a level of professionalism. That's what we think. So this may include, you know, visual inspection, testing, adjustments to the processing parameters as needed, right? Like most process manufacturers, you need a great QA team, right? And QA is quality assurance team, right? You need somebody who likes, you know, get their hands in there, inspect, look, right? And they know that they are pretty much the last line before it goes out to the customer. It's a huge importance step for process manufacturing, I think. So I think that touches on that a little bit. And as well as, like I said before, this one as well goes into textile, automotive, composite materials, right? Construction, the hempcretes, the paper making, right? Imagine hemp wallpaper at some point in time. It's coming, right? So here is an outline. We try not to get too much into the short and the long fiber, right? Because we know that we have more leadway right now with the hurd and the shiv. But I think that this is an important note so that people who have interest can understand what lengths are desired, right? Especially for fiber lengths, anywhere from 1 to 6 inches, right? Which is ideal for producing smoother, finer yarns, which are durable, less prone to fraying. Also, one cool project that we've seen is them being reintroduced to canvases. The root word of cannabis is canvas, right? So we're about to see, you know, artists get very we would say, back in their element, so to speak. I'm not saying, they're all about cannabis, but, most artists I know are. So, that's just me. But even on that side, right, we noticed that the fiber length is going to range, right, from a 0.8 to 3 inches, right? A little bit different, right, because it's a little bit more coarse, right, suitable for creating tougher, bulkier yarns with good tensile strength, right? And that also ties very much into the insulation that a lot of folks are seeing in the field right now. It's not fireproof, but it's really nice, easy to integrate, right, and less carbon intensive, right? And then the non-wovens, right, like the geotextiles, the mulch mats, the industrial materials, right? Same thing, right? Just 0.8 up to about 2 inches, right? 3 gets a little weird. We've seen them start to fray. We did a study in 2019 through 21 with a group based out of South Africa, and they were just all over this stuff, anywhere from trying to make surfboards to all kinds of things, right? But they too knew that they needed this eventually for building in their built environment. They just weren't there on a policy level, right? Much like a lot of us have been up against, right? The policy has restricted in a way the progress, but that time has passed, my friends. So, yep. And the same thing, technical for the textiles and composites, right? Anywhere from automotive to building materials. You're going to see this a lot in the fishing industry. We get a lot of inquiries. And that's about 2 to 4 inches, right? These lengths provide a balance of flexibility and durability necessary for specialized textile applications. Now, here's one of our tables, right, where sometimes we fray stuff apart. One of the early products that we started to do just for promotional goods, to be funny, was like, when you go on an airplane and you throw the thing around your neck and you're like, oh, I don't want to, nobody wants a stiff neck on an airplane, right? So we're like, hey, maybe we can hit that market. We were like, hey, what do we do with all this excess material? Because at the time we were using most of the herd material for animal bedding, right? And then some small builds, right? Our state is really big on ADUs and DADUs. We lead in the energy efficiency update, right? All the new CI updates that are coming. Primarily anything in the energy code that becomes what it's going to be for the United States usually goes through Washington State first, right? There's a reason why we have George Washington up on there, right? Up on our map, right? This dude was hella into hemp, and he definitely liked to do things first, right? So for those of you who are like, well, all right, well, what does a full system look like, right? Now, some of you may know there's a system called the LaRoche system. This thing is anywhere between $7 million to $30 million. I don't know about y'all, but we didn't start out with $30 million, and we couldn't get a bank to give us a loan for even $3 million, right? So, when we talk about this, right, this is a great system. I think this is why so many people refer to European being the standard, just because they've worked to make sure that their standard was the global standard and nobody else can outcompete them. I think that is going to change, right? There's a lot of innovative manufacturers, especially in the United States, who are going to find ways to do it better, more cost efficient, create more jobs, get products to market, right? We have to. It's not feasible sending all this material across the water when you should be able to get it within 300 miles within your region, right? So the purpose of the function, right, the decortication, right, it's designated to separate the bast, the long, strong outer fibers from the herd, which the woody inner is core of the hemp stalk. And the goal was ultimately for this machine, which we've seen, which is huge, is to efficiently retain the quality and the length of the fibers, right, which are crucial for multiple industrial applications, right? Now, that'll vary, right? Like I showed you before in the size. As long as you know your size and you have screeners, you should be good, right? It has some really cool technological features, right? The decortication lines are good, all the way to the bale breakers, which is something I didn't talk about, right? Once you get the bales in, right, you need to break those bales open, right? So some machines like this one has a bale breaker already built in, where you drop the bale on, rips it up, sends the material down the line. It's kind of beautiful in a sense, but also very expensive, like I said. But I'm rooting for you. If you can get that $3 million, 30 million, let me know. So this machinery, right, typically includes, there are modules for feeding it, opening, cleaning, refining the fibers, and it does require, this is a full time. You need FTE employees, right? You need to be able to make sure that things are not getting mucked up, right? Because if this machine goes down, we are talking massive technical debt here, right? This is part of the reason why, which I'll talk about very soon, that we decided to go to a smaller scale, right, and be able to be more cost efficient, still be able to produce material that was viable, right? So I know we're running a little tight on time, so I'll kind of speed up. So if you read here, the technology features, right, does offer efficiency and productivity, right? And there is some innovation and sustainability once upon a time. But these systems, right, have been around for a little while. We do believe that there are new ways, and we have found some. So, but this machine in its entirety, you'll see the materials that it pumps out, right? Bass fibers, some virgin fibers, right? Some clean fibers, and ultimately the shiv and the herd. Now, one of the things that a lot of people get really, I think, really desire, we once upon a time did as well, was the cottonized fibers, right? But when you think about when you start to cottonize a material, it loses its value, right? This is a whole another module that we can go on. I think it's an important factor because a lot of people can get lost in the sauce trying to cottonize this as if this is something else. Now, if you go to ASTM and you go a lot of these other technical things, there is no standard for hemp, right? So the standard that everybody pretty much goes off of is cotton, right? So, but on a vibrational and on a frequency level, on a physics level, which we've done some light testing, is that this material loses a lot of its value. Much like if you've ever worn anything synthetic or lived inside of a home that has anything synthetic, right? It starts to burn, it dries you out, right? Cancer causing agents, certain things that become more possible. I'll leave it at that. So innovation and R&D and hemp processing, right? To produce a competitively priced installation product, reducing processing costs is crucial. That's definitely what we found out at the foundation. Through our focused research and development efforts, we have developed a highly efficient processing strategy, right? Which I was trying to allude to, saying that, hey, if there's a will, there's a way, essentially, right? There is no one way. There are full systems, but there's ways to be able to set up yourself up to be successful, right? In any region, any city, any town, right? We utilize strain-specific hemp, right? That naturally produces large amounts of herd shiv material, right? That's a huge area, right? Knowing what you're going to be able to get in, because then you're going to have an idea of what those bales look like, how you're going to take them in, and then also give people a gauge, because when you bring it in, you're also weighing the bales, right? You're going to be like, hey, right, this is how much I can give you, right? We do flat farm pricing, but sometimes we do by the bale. Depends on the region. That's a whole nother conversation, right? But this early intervention results, right, in smaller stocks pieces, which are more efficient, right, to be fed into hammer mills, right, like the one on the right, right, which precisely turn to achieve the required particle size for the hemp line production, right? So one way or the other, there is a way to get it essentially, right? But what we've found is that there are ways to definitely reduce the cost and assure yourself that as a business, you can deliver materials to market, right? Right. And one thing we learned, because we just, nobody gave us real much credit, right? That's really not what it's about right here. The mission is greater to deliver healthy materials, right? But, we got a lot of scorn, for telling people, hey, you can do this for much less, right? Because then, we're taking money out of European hands, so to speak. And, I'll be the first to say, I'm definitely grow in America, made in America, right? This is our opportunity right now. We've outsourced so much manufacturing. We need to be doing this here. Right. So to help enhance that, right, from using other stuff, right, I go back to the screening, right? So anywhere between hammer mills, shredders, screeners, right, you're going to be able to get where you want to be, aka the promised land. So hammer mills, shredders for initial breakdown, right, utilizes high-speed rotating hammers to crush hemp stalks, facilitating into size reduction. You screen the size, right, within the mill, which will dictate the course of the sizing, tailored to specific application needs, right? And then more screening for precision sizing, right? You could follow up with a vibrating or rotary screens, which will refine the shiv or herd, right? Size for consistency and quality. And, some of the screens that we have found, definitely screenshot this, is anywhere from 1/8 to 1 inch, right? Which will help sort the shivs or the herd by size, and oversized particles to be reprocessed, right? So you need to throw it back through a second loop. But you also find people who do like the larger chunks, which is something that is going to be coming to light, we think, over the next 1 to 3 years, just because we've had some very intelligent folks reach out and they were like, yeah, this is what we're doing. I was like, yeah, we think you're right. So some of the key benefits of integrating different processes, right, is we can still maintain efficiency. We can still get consistency, right? But the thing that we help, right, with an American market where we're trying to grasp, right, either through grants, private funding, right, VC, is that we're creating cost effectiveness, right? Most people don't want to hear your cash flow or you're going to be putting out X amount of dollars, right, without any reward immediately, right? Very few companies can function like that, right? This is a way to make sure that, hey, if you're trying to provide for your region, you can do that, especially in a state like California, multiple regions, right? You should be able to provide for your immediate, 50 to 100 square miles, right? You got a lot of agriculture out there, much like Washington, much like Oregon, the Pacific Northwest, right? All the way over to the heartland, right? And what we're seeing with our brothers and sisters in the South, right? In the eastern border. So right here, this is material that comes out of our line that we've been able to ascertain, right? And it talks about all the values that we said before, right? Some of them were done through one pass, some of them were done through two pass. That's definitely something to factor in when it comes to hiring folks, right? Because your work sessions may be a little bit longer. Some people may work 6-hour shifts, some may work 8-hour shifts, right? And then some, being able to match up like, hey, you did your first pass, then come back, right, and do your second pass, right? So there's a way to stagger your production lines, right, as you get this material. What we can share is that from staggering that allowed us to be able to develop our manufacturing side, right? That's where we were able to be like, hey, we can now create products, right? Because we have time now, right? Before, when you're trying to sweat it out and figure out how to get this stuff all through the machinery, right? It's time and labor consuming, right? Especially when you're trying to dial it in and get it right. Here's another one. The other one has that powdery material, right? This right here is going to have a lot of impact in the building industry, we think, right? Anywhere from finished pastes all the way to 3D printing to other areas, and that is a byproduct, my friends. This plant is the plant that just keeps on giving. So even when you've broken stuff up and you think like, oh, there's just a pile of this over here, and what the hell would we do with that? It has value, and these markets are coming, right? Especially anybody with a material science background, right? Their eyes are gonna start to get real big, right? And I'm sure more than many of you have started to notice, like, hey, they're parallel industries, right? Almost out of here. I know it's dinner time for me. I got 3 little ones downstairs screaming for me. So our innovations, right, have really come through R&D, right? This was stuff that we weren't even supposed to be here, right? I'll be real frank. In our state, 0.8% farmers are people of color, right? And those who are in the manufacturing space is 0.5%, right? So us taking a swing at this was, kind of like a Hail Mary, so to speak, right? I know in the word it says we're all created equal, but when we look at the global history, we know that's not the case, right? So we're super thankful to be able to have done years of R&D, which some of you, I'm sure, out there in the field have done, right? Especially some of our South American friends, right? But, our ongoing research and development have played a pivotal role, right? Leveraging these integrated systems to their fullest potential, right? Through comprehensive R&D, right? We've been able to fine tune our processes to create stuff, right? Anywhere we create the hemp lime blocks, the hemp lime panels, right? And as well as we have another product that we just signed a partnership with a group called Carbon Bricks. Right? These things we think they're going to be really, really, really cool, which has led to a significant boost in not only the environmental benefits, right, that more people can now understand, but also in the generations that are coming behind us, right? We do a lot of events where it's, green jobs, green futures, and we see a lot of high schoolers to new colleges, new college students who are saying, how are we not using this material already, right? It's a great question, right? But, to reduce the overall cost, right, we just had to factor in so many different things, right? And as you'll read below, right, maximizing the carbon negativity through the integrated systems, that's been something that's been really, really a huge part of us. Much like Alex had shared, there's a really cool company called Hempwood, right? They have a whole system where essentially they're just taking all their energy, putting it back into the inputs, cycling it over and over and over. We do a very similar thing up here, right? Because we have so much timber as well as some of the waste here, right? You can use gasification processes to literally fuel your whole system, right? So this is something that you can find in a FEMA book, right? For any architects or any urban planners out there, this information exists, right? The thing about this material we find is that, it's been used by those who had a need massively, right? And found that this would be the lowest cost, right? So our goal as a producer processor to make sure that this cost doesn't get crazy, right? Doesn't just go for the people who want the baller mansions to be made out of hemp cannabis, but we want to make sure that it gets back to people, right, like in affordable housing, right, and new developments coming up. So streamline manufacturing and local sourcing. Also, oh yeah, let me touch. We did during this thing on the R&D, we created our own binder, right? We have natural pozzolanic, great materials and minerals, earth abundant materials here in Washington State. We've been able to create a binder that works for all hemp builds. We think it's going to be really, really good. We have it going on a couple of projects right now. If you ever have a need, hit us up for sure. Light marketing, a little push right there, but you should be able to. A lot of regions have materials like this there, right? It's just a matter of being able to put it together at scale, right? And that takes time, right? So be patient with yourself, right? You can do it. If you don't think you can do it, call me. I'll tell you can do it. You know what I'm saying? You'll be able to do it, right? And then understanding the LCAs, right? Because a lot of this stuff which we see with the whole construction industry in itself, it's going through a whole new branding, right? A lot of the bags, the packages, any of the material that's showing up on site, their LCAs are changing, right? Right, they're changing, and that comes at a high price, right? So, yeah. So what if profitable local agriculture was connected to healthier buildings? Ding dong, it is, right? It is. Here we are, right? Spending our time at a 6:30, and some of you may be, way farther into the night, but we know that this is absolutely connected, right? We wouldn't be showing up here if it wasn't, right? And now we have hemp growth incentives, right? We have incentives from our state. As a company, we received a grant last year to do outreach, right, for green jobs, green futures, right, to educate people on what hemp is, right, and how it can be used, right, how it's processed, and to engage more farmers, right? So I think this is something that's going to be rapidly pushed all over, right? Agricultural based production system, right? This is a fiber crop, right? It's USDA, right? People should qualify. There's nothing different, right? This is classified as a fiber, right? A commodic fiber. That's it. It's not any more complicated. And then opportunities for farmers, right? There's a lot of small farmers out there who, really small, 3 to 20 acres, right, with hay, and they would love to fit this into their rotation. So this has been a really, really good thing that we've seen. Worker training opportunities, like we said, workforce development is huge, definitely on our mind because, we don't have enough people out there to construct. We got a lot of dreamers who can draw, right, but we need more people who can build, right? So. And then the healthier building designs, right? Alex showed some really cool stuff. There's a lot more out there too. And, the USHBA is definitely a proponent trying to make sure like, hey, we have stuff that we can rinse and repeat. Leaders like Amanda Martin and other individuals like that. So on the economic boost for urban and rural communities, this is where my heart is, right? I was one of those kids who, lived in a small town of 70. My parents split and my dad moved to New York, the Bronx, New York, right? And I was like, whoa. I'm living in the city, right? People are wearing saggy pants and doing all kinds of crazy stuff, right? So I was like, what's going on? But you could see the blight. There is blight everywhere. There's poor materials everywhere, right? And this is our opportunity in our lifetime to do it, right? So I wanted to give a shout out to other American processors out there because respect is when respect is due, right? And we have been able to work alongside, have conversations with these groups over the last now 5 years, right? Formation Ag takes a pretty good swing. You'll want to do your own due diligence on that. Western Fiber right there in California. Hemptexture has taken their swing and has moved to the finished I&D Hemp group. We actually helped tool one of the first ones that they got for R&D. Bish Enterprise, these guys are crazy when it comes to the harvesting equipment. I mean, they've got sickle bars that are just, I mean, you can it looks like you're showing up for Warzone or something, but that crop's going to go down real quick. Let me tell you. We have Carbon Bricks. We have Tiger Fiber, who's doing really good. Hempwood, who we love, right? And then we have a Southampton down in Kansas, right? And we have our own Minority Hemp Builders Association, which we push up. And obviously, we have to put ourselves in this map because that's what we do, right? We did it because we figured, hey, how else are we going to get these products to market, right? Or else we rely heavily, and don't take this the wrong way, we're going to be relying heavily on the universities who were like 3-4 years behind, right? Because they all invested in cannabinoids. They didn't invest in the fiber. Let's be honest here, right? So it's on entrepreneurs, professionals like yourselves, right? Architects, leaders, industrial designers, interior designers, dreamers, doers, right, who are going to be able to help push this a lot faster, right? We already have builds, right? Why would we still be in the university phase? That's one person's opinion, right? So if you contact us, you see this diagram in the back, it's all you would ever need. It's all you would ever need, my friends. I can tell you exactly what to do, but I couldn't give it away all right now, right? Because you got to call me, right? You know what I'm saying? I'm not Miss Cleo, but I got a hotline. You can call me, and I'll give you some fortune telling for sure. So, you can find us at biofiberindustriescom, right? info@biofiberindustries.com is the best email. You'll get somebody from either myself or our team, right? Or if you do the Instagram thing, come check out some of the stuff that we got going on. Biofiber Industries. Yeah, I know it's a very long handle, but we tend to be a little bit more linear than most. So that's just how we kind of function. So I'll do that again. Boom. And here's one of our walls that we just finished. Got to do. So it's pretty cool. So with that, I want to say thank you. Thank you for making the time. Thank you for caring. Thank you for being a professional. And let's build better.
Ashley, thanks so much. That was awesome. I feel like that's the piece that we miss in a lot of these conventional construction webinars. So thanks for taking it back. We've got a few questions. So in the interest of getting out of here shortly, let's run through them. This one is focused on, well, embodied carbon. Since hemp processing can go in so many different directions and there are so many options, do you all keep track of embodied carbon data for different types of processing?
Yes, that's what kind of led us to the pyrolysis effect. Initially, all of our math was done around cubic square foot or how much mass, right? And that was still more on the building side. But then we're like, well, if we're manufacturing and processing, our input is still impactful, right? So we had to figure out, initially we had equipment that was like running on a diesel generator. And we're like, all right, let's use that. That's a lower input. We're doing pretty good. But then we realized we're like, no, we're still emitting, right? So it's one of those challenges where I think on a process level, it's always going to improve. Sadly, it's definitely comes down to if you have enough capital, or you can have some systems that are already kind of built in that you can have. But definitely something that was on our realm of thinking when it came to being able to actually bring it in, and that was kind of like why we always factored, hey, like we start our carbon count from the time that this material leaves the field, right? And then part of the math that can adjust that, right? So you are still emitting a good amount or a little bit carbon intensive doing your processing side, you can always factor in the amount of carbon that was potentially absorbed from the actual field, right? That math has been super helpful, right? Where we're saying like, hey, how can we get to at minimum being carbon neutral? We know the material is, but how can we make sure that the whole process and everything that goes into the whole thing gets neutralized? So
Awesome. Let's see. Hemp versus straw. Is one more versatile than the other? And if so, how?
hemp versus straw, like straw in regards like hay.
I
I
would
mean,
say like straw, like a straw bale home or that sort of construction.
yeah, I would leave that to the engineers. I do have two on my team, and I know Naheli would love to answer that. But I would say, from what I've heard, there is a little bit more integrity, especially when it comes to the formulation, right? Because not all binder mixes are the same, right?
Right.
So when you have a bale house, right, or a bale barn, right, we see a lot of those in California, right? It's a different type of composition, right? We did try to see if we could take bales and build a little cabin, just like with the hemp bales themselves, just to see what it was. And it was good. It was good. We definitely noticed, there's, some nature friends out there that like to hang out. But I would say I would lean towards this material being a little bit more superior in its strength, just because of the binder. The straw, right, is generally just straight straw, right? At least from my experience.
Can you talk about biofiber as a business and how business is, whether you're growing, uh, and who you are selling to?
Sure. Yeah. We're definitely growing, right? That's thankfully, right? Because it's not easy when you look in the account or you look at your cash flow, right? And you're saying, hey, like, what are we doing here, right? The land of R&D is not for the meek, right? You know that you're pouring dollars into something that you have no guarantee. So the uptick has been this past 2 years, right? We've been getting a lot more small builds, anywhere ranging between 700 feet to 1,500 square feet. We also just have a deal going for a 33 house development with a group up here, Northwest Living Institute, which is really good. And we've made quite a few sales when it comes to, you know, entertaining other markets like the animal bedding and some of the stuff, which, on an ethos level, I wasn't really down because I thought the material needed to go to homes, right? But then when you're in business, you're like, well, how are we making money? Right? You're like, how do we make money? What are we doing right here? So it's been good. We're definitely think that we're on the phase of growing. We now know that we qualify for bridge loans, for traditional lending, right? That just wasn't there before, right? If you're a farmer, if you're a process manufacturer, right, and you show that you've made some dollars, right, and you're showing, hey, this is the forecast of what the future looks like, right? We see it in tech all the time, right? We see it in tech all the time, right? They have zero product, but they've been able to raise like 5, 15, $30 million, right? But a lot of people associated this with the chemical side. It kind of negated that. So that is part of the reason why I say, like, we feel really confident. We've even had all the way to the VC level, right? Which we're not necessarily entertaining to its full unless it's the right fit, who threw us to the side. And, in the last couple of months, we've been reaching back out saying, hey, we're into bio-based materials now. It's like what Alex was saying, right? Like, you couldn't say the hemp word, right? It was like the bad word, right? Like all of a sudden people would just shun you. Like, oh God, this guy's another hemper. Jesus, get him out of here. But now it's cool, right? Because I think a lot of people who are in positions of quote unquote power, whether it's in the policy, whether it's on the financial markets, right? They have some form of history and culture towards this plant, right? And they're like, well, this is our opportunity to get this going, right? This is our opportunity to actually make it happen. So I hope that answers that question.
Awesome. All right, last one. Let's see if you can make sense of this. Can you harvest and process legal or illegal NorCal crops, or would that be illegal?
I love that question. That's a very, very good question. If I'm understanding the question correct, are you able to take crops that are like that have cannabinoid in them technically? Well, I'm going to say yes. And here's the thing. So I lobbied for the last 2 years because what we had to do was take material from what is up here called I-502, right? You had to pay for a clean air permit, right? And you got to dump a lot of money to be able to even do R&D, grab this material from that market. What passed is called SB 5873 up in Washington State. This is something that you want to take to your policymakers in California, and this will do a big thing. Also know that there will be competing interests in here. But what we were able to do with SB 5873 was basically make it so that any of the material that comes from the other side of the space, the cannabinoid space, we can take that material and use it, right? Essentially, we can upcycle it, right? We think that this is a huge, huge move for the industry that other states will eventually get on, right? It just takes time, right? Now, if the twist on that question is asking, hey, can you grow, take your Cali crops, right, that don't have a license, don't have nothing, right? And like, hey, can I send that over there to process? I don't know what the legal language is in California, but in Washington, you can, right? Because essentially, right, this is something that a lot of people don't want to hear, and usually lawyers charge a lot of money for, is that until they test it, it's all hemp. It's all hemp. That's all it's all it ever will be, right? Until you actually test the thing, right, for it, right? And if you're growing fiber-centric strains, there will be no crystallization and resins that will ever peak that. And that's because it comes from generational strains T1 through T7s, right, that come from outside of America.
Interesting.
I wanted to add to that. So, in California, so when I first started getting into this, that was one of the things that I wanted to do was take the essentially waste, with the little raptor claws waste, air quotes, and why not use that, in hemp homes or any type of other building material. And there are it is somewhat frowned upon, but there are loopholes and you have to get a license as someone who that license requires you have so many tons of this waste. And it's considered, and I think Chris could speak to this too. I think we had discussed this when we were working on his house, but you have to have I'm drawing a blank on what it is, but there is a license that you can get to allow you to take that waste. And I believe that covers you, and it depends on what the licensing is for the processing centers or wherever they are, but you can use that license to process that waste and utilize it in California.
Awesome. All right. Well, approaching 7 o'clock, I think we'll close things out for the evening. I did have AIA learning units available for this, so you would have input your license number when registering for the class. If you had any issues with that, reach out to me directly or through the info@ email that you received the registration correspondence through. Otherwise, I will be sending out slides and a copy of the recording. It's an automated process, so it should go out before the end of the week. Yeah, and with that said, we do have another one of these coming up in May. Be sure to check out our event calendar for that event in particular and anything else that piques your interest. With that, enjoy your evening and thank you.
There is also going to be a hands-on workshop in June.
Perfect. Yes. Yes, we'll be doing a hands-on workshop in June at McGrath Family Farms in Ventura County. Registration and some more information to come soon. All right, y'all. Enjoy your evening. Thank you.